Welcome to The Explainer. You know, when we think about the global waste crisis, our minds usually jump straight to physical things, right? We picture plastic bottles washing up on beaches or rivers totally clogged with garbage. But the actual roadblock preventing us from pulling off a coordinated global cleanup isn't physical at all. It's an invisible crisis, and it's buried deep inside our data. Right now, researchers, governments, and citizen scientists all over the planet are trying their hardest to measure this waste, but they're hitting a massive wall. Let's decode exactly what's going wrong.
So how do you actually count the world's trash? I mean, it sounds like a pretty straightforward logistical challenge, doesn't it? But really think about the monumental task of combining data from urban rivers, deep ocean trenches, estuaries, and land ecosystems. You've got information coming in from thousands of completely different organizations globally. The sheer complexity of tracking mismanaged solid waste on this scale is absolutely staggering. And as it turns out, the biggest obstacle isn't physically picking up and cataloging the trash, it's the vocabulary.
This side-by-side comparison perfectly captures the absolute headache that data analysts are dealing with every single day. Just imagine two different environmental groups surveying the exact same stretch of polluted beach. The first group jots down that they found fishing gear. The second group, maybe trying to be a bit more precise, writes down fishing pole and fishing wire. Now, they're describing the exact same garbage on the exact same beach, but these two data sets, you can't easily merge them. As an analyst, there's no mathematical way to accurately convert a broad category like fishing gear into specific poles and wire without making some massive assumptions. They simply don't speak the same language.
Section 1. Clashing classifications, the root of the chaos. Let's dive into why standardizing this data feels a bit like building a modern-day Tower of Babel.
For decades now, environmental surveys have heavily relied on a methodology that is fundamentally flawed. We call them use-based categories. Broad terms like smoking-related or construction materials might sound pretty helpful if you're just looking for a really quick summary of your local park, right? But behind the scenes, they completely break standard database rules. In practice, they create absolute chaos for the environmental analysts who are trying to build accurate, actionable global models.
Let's break down exactly why a term like smoking-related fails so spectacularly. By using a category like this, you're inherently tossing completely different items into the same bucket. Think lighters, glass pipes, and cigarette butts. And because you're mixing items, you're obviously mixing materials too. Plastic, glass, paper, organic stuff. But here is the real kicker. It relies entirely on the subjective assumptions of whoever is holding the clipboard. One organization might log a plastic lighter as smoking-related, while another team down the road decides, no, that belongs under household items with the plastic spatulas. The end result? The global data is functionally incompatible.
Which brings us to Section 2, the Trash Taxonomy Tool, a universal translator. This is the relational database solution built specifically to clean up this messy data problem.
To really understand how this tool operates, we first need to define its core goal, which is harmonization. Now, crucially, harmonization is not about forcing every single organization on Earth to adopt the exact same rigid survey. No one wants that. Instead, it's about developing taxonomic frameworks that facilitate operations between both established and brand new surveys so that all these distinct data sets can readily work together. Think of it like a highly sophisticated mapping system. It takes everyone's unique, localized data and seamlessly translates it into one shared, universal framework.
The tool pulls off this translation using two incredibly simple but incredibly powerful rules. Step 1 is the alias rule. This tackles synonyms. If Survey A logs a cap and Survey B logs a lid, the database instantly steps in and says, yep, those are the exact same primary item. Step 2 is the hierarchy rule. This is essentially a multi-level grouping system that logically nests child items under parent items. So a fork and a spoon are nested neatly under the parent category of utensils.
Let's follow this hierarchy visually. Picture a volunteer out in the field. They find an unlabeled, sun-bleached bottle sitting on a riverbank. Using this system, they don't have to guess the brand or exactly what kind of juice used to be inside. They can confidently classify the material as hard plastic, which naturally sits right under the broader plastic category. Then, for the item class, they just select beverage bottle, which cascades perfectly under beverage containers. It's brilliant because it allows for immense analytical accuracy without ever forcing volunteers to make unscientific, wild guesses in the field.
This design philosophy leads us to a really key insight from the researchers. They noted that this allows for more general and more specific terms to be used simultaneously. And that is a real game changer. Because of this elegant structure, localized citizen scientists don't have to sacrifice their specific regional details.
If they want to track a hyper-specific type of local fishing wire, they absolutely can. Thanks to the hierarchy and alias rules, that specific local data smoothly rolls up to contribute to massive, highly accurate global models.
Section 3. The 20% overlap, a fragmented landscape. Now let's see what actually happened when researchers tested this harmonization tool on real-world global surveys.
Okay, brace yourself for this number, 20.8%. Out of 68 major global English language surveys analyzed. And we're talking about the big surveys relied upon by governments, nonprofits, and academic institutions. They only shared an abysmal 20.8% of their item classes in common. Less than a quarter of the language being used to describe global pollution was actually shared across the board.
Just look at this scatterplot. Notice the massive clustering of dots pushed all the way down to the zero lines on both axes. The x-axis here represents item comparability, and the y-axis represents material comparability. A huge majority of these survey pairs literally share 0% comparability. Zero. If you tried to mathematically merge these 0% surveys without the trash taxonomy tool stepping in to act as a translator, your global data set would be entirely corrupt and completely useless. To really hammer home the severity of this knowledge gap, let's look at the hard stats. Across the board, there was only a 29.9% average overlap for materials. Over 2,100 specific list pairs were exactly 0% comparable for items. And honestly, the most shocking irony, statistical analysis showed no significant difference based on organization type or the ecosystem being studied. Oceanic researchers and terrestrial scientists literally cannot speak to each other through their data. The lack of a shared vocabulary isn't just a minor hiccup, it's a universal systemic crisis across the entire environmental sector.
Which leads us to Section 4, Beyond Counting, holding producers accountable. Why does fixing a dry, technical database problem actually matter out in the real world?
Well, look at what harmonized data actually unlocks for us. It finally allows us to aggregate those massive global data sets securely. And when we can do that, we can identify crystal clear targets for mitigation anywhere on Earth. With a unified language, advocates and lawmakers are empowered to engage in rigorous upstream policymaking. It equips them with the irrefutable data they need to accurately trace environmental pollution right back to the source, enforcing something known as extended producer responsibility.
To put the scale of this newfound accountability into perspective, check out the brand audit capabilities. The alias tables within the tool don't just sort generic plastic. They can trace 3,740 unique littered brand classes, down to the specific logos found decaying in the dirt, straight back to 1,239 distinct corporate manufacturers. By harmonizing the terminology, thousands of individual pieces of litter can be unequivocally linked right back to the exact companies who designed and produced them. This lays the empirical foundation for true, undeniable corporate accountability.
We're constantly inventing new materials, complex bioplastics, and constantly evolving consumer goods that ultimately find their way into our ecosystems. The trash taxonomy tool is an absolute breakthrough for standardizing what's already out there. But here's the big question to leave you with. As our trash relentlessly evolves, can our shared language aggressively adapt to keep up? Because at the end of the day, saving our global ecosystems literally depends on our ability to properly name the problem.